Hello, welcome to my channel. We will be solving this exam today. Uh, yes, this is May-June 2025, Vision 1-3. Okay, so let us start. We have question number one. It is fairly easy question. You see, you have a polynomial function. Okay, and the critical points here, you can see that this is one point, this is second, this is third. So in general, this type of function, we know it is something like this. It is y equal some constant into x plus a, x plus b, and x plus c. That's these a, b, c are the points where this is crossing, becoming zero, basically. Okay, so let me make it little thin. Okay, so in this particular case, we know that it is k, some constant, we don't know it yet, x plus a. So if I started from here, it is basically it is x minus a. The a is the value of this intersection. So when I put it as x minus 2. Okay, so when x is minus 2, it becomes 0. This factor becomes 0. In the same way, the second one is x minus 1 half. And the last factor is x minus 1. Okay, so this can be further simplified. I can say if I multiply multiply by 2, then it will become k by 2, and then x plus 2, and this will become 2x plus 1, and then x minus 1. Okay, now second information is this one, that when x is 0, the value of y is minus 2. Okay, so if x is 0, y is minus 2, so this is equal to k by 2, and since x is 0, so I have 2 here only, x is 0, so I have 1 here only, and x is 0, so minus 1 only. Okay, so this simplifies to be minus k. So from here we can say that k is equal to 2. Okay, now we have everything, we can plug it in, and we have this equation that y is equal to k is 2 into x plus 2, and then x plus half. I should use this expression. Yeah, okay, let me write it again. So y is equal to k is 2, so 2 over 2 is 1. So I have x plus 2, and then 2x plus 1, and then x minus 1. Okay, so this is our final solution. You can see a is 1, right? And b and c, either one could be 2 or minus 1. Okay, so this is the end of our problem. Okay, now yes, use the graph to find the values of x for which y is greater than or equal to 2. Okay, so let me do it this way. If I put a line where y is equal to 2, so that line would be this one. Okay, so now I have to find the values of x when the value of y is more than this one. So you can see this is one value, and uh, this is the other value. Okay, so x must be less than minus 1, less than or equal to minus 1, and greater than or equal to, this point is minus 1.5, this is minus 1.7, minus 1.7. So x has to be between this one, or x has to be more than this value, right? And this is 1.2. So x has to be greater than or equal to 1.2. Okay, so this is the answer for part B. Okay, part B this way. Okay, so this was our question number 1. Okay, let us do question number 2. It's also fairly simple. Find the values of k for which the equation has two equal roots. Remember, a quadratic equation has equal roots when the discriminant bit is b square minus 4ac. This part is 0. Remember, the solution of a quadratic equation is x is equal to minus b plus minus under root b squared minus 4ac divided by 2a. So this part is 0, then you have both roots are same. Okay, both roots are equal. Okay, so b square minus 4ac is equal to, you see my b is 4a. So this is 4k, sorry, 4k square, and minus 4 into a is 1, and c is this one. This is the constant term c. So I will put k plus 3. Okay, k plus 3, and this should be equal to 0. Okay, so you can see this is 16k square minus 4k and minus plus minus 12. This must be 0. So I need to solve this quadratic equation to find the values of k. Okay, so from here you can see if I divide everything by 4, it will make the equation a little bit simple. It will become 4k square minus k minus 3. Okay, this must be equal to 0. Okay, 4 times this is minus 12, and factors are 4 and 3 minus and plus. So this is going to be 4k square minus 4k plus 3k and minus 3 equal to 0. So if I take 4k common, it will be k minus 1. And from here I will take 3 common, that is k minus 1 equal to 0. So I have k minus 1 and 4k plus 3 equal to 0. So k must be equal to 1 or minus 3 by 4. Okay, so these two values of k will give equal roots for this quadratic equation. Okay, if you have time in the exam, I would suggest that you substitute these values of k and make sure that this quadratic equation is giving you equal roots, just to confirm. Okay, now question number 3. Okay, we have this polynomial. Okay, yeah, where a is a constant. When this polynomial is divided by x plus 2, the remainder is 84. Okay, okay, so let's try to use this information and find our constant a. Okay, so if I divide this polynomial x cube plus ax plus 30 by, I'm doing this long division, x plus 2, the remainder should be 84. Okay, let's see. So if I multiply by x squared, so it's going to be x cube plus 2x square minus plus minus, this will cancel, and I have 2 minus 2x square plus ax and plus 30. Okay, now I will do it with minus 2x. Let's become minus 2x square and minus minus plus, so plus minus, and 4x. Again, plus minus become plus, this will cancel. Here I have, you can see, a plus 4 into x plus 30. Makes sense? Okay. Now next I will multiply it with a plus 4. This is my constant. So a plus 4 times x is a plus 4 times x, and then I have plus 2a plus 8. Okay, let us subtract. This is positive, it becomes negative, positive, negative, positive, negative. This cancels. Now we have 30 minus 2a minus 8. Okay, which is 30 minus 8 is 22 minus 2a, and we are told that this is equal to 84. Remember, the remainder is 84. Okay, we will use this information and find the value of a. So you can see if I divide everything by 2, it will become 11 minus a equals 42. So a is equal to minus 42 plus 11, it will give you minus 31. So a is equal to minus 31. This is the value of a we found. Okay, now they didn't ask you to find them. Okay, write px as the product of linear factors. Okay, now I know that my polynomial px is equal to x power 3 and a is minus 31x plus 30. Okay, and now I want to express this polynomial as factored in factored form. Okay, so since it is a cubical expression, there's no closed form solution. Okay, but finding the first solution is difficult. Okay, will you hit and try? So let's say if x is equal to 1, if I substitute x equal to 1, it will become 1 minus 31 plus 30. So this is 1 plus the 30, and this is 0. Okay, very good. So it means this is a factor of this polynomial. It means x minus 1 is a factor of this whole thing, this big polynomial. Okay, so what can I do now? I will do again long division, x cube minus 31x plus 30, and I divide it by x minus 1. So it will give you x square, x cube, and minus x square. I put it here, minus x square, subtract plus minus, it cancels, and I have x square minus 31x plus 30. Next, I will multiply with x. It will be x square minus x. Again, plus minus, it cancels. So minus 31x plus x. So this is minus 30x plus 30. So next is minus 30. It has become minus 30x and plus 30. So I have left everything. Okay, good. So my given polynomial p of x can be written as one factor is x minus 1 and the others are x squared plus x minus 30. Now you can see this is easy. We have one quadratic factor. We can factorize it easily. Okay, so x squared minus x minus 30. How would I factorize it? This is minus 30 and 6 times, no, 6 times 5. Yes. So if this is minus, this is plus. Summation is minus 1 and some, yeah, okay. Okay, so this is x squared minus 6x plus 5x minus 30. From here, I will take x common. So it's going to be x minus 6. And from here, I will take 5 common and it is x minus 6. So it is x minus 6 and x plus 5. So I have x minus 1 and x minus 6 and x plus 5. So this is my the polynomial in the factored form. Okay, easy, no question. I hope you understand everything. You're following me. Okay, let's move on to the next question. Yes, this is a little tricky. Okay, solve this equation. Okay, so let me write it down. It is 2 over log of 10 base x. Okay, minus log of x plus 4, and this is equal to log of 2. Remember, these two logs are base 10. Okay, so what do I do? Let me take this on the other side. So I have 2 over log equals log of 2 plus log of x plus 4. So this can be combined together in log 2 times x plus 4. No problem. Okay, if I take this on the other side, it will become 2 equals log of 10 base x multiplied by log base 10 of 2 into x plus 4. Am I right? And remember, we talked about it before as well. So if you have log of a base b into log c base a. So these two things cancel. You can say an answer would be log of c base b. Okay, so same thing happening here. This 10 on this is x, so this will become log of base x 2 times x plus 4. Okay, now we have something tangible in our hand. Okay, if I convert this log expression into exponential, it will become x power 2 equal 2x plus 8. Am I right? Now this is a simple quadratic equation. We can solve it. So x squared minus 2x minus 8 equals 0. So factor if minus 8 can be done as 4 times 2. This is minus, this is plus. So x squared minus 4x plus 2x minus 8 equals 0. So from here I will take x common. It's going to be x minus 4 plus 2 common, again x minus 4. So we'll have x minus 4 and x plus 2 equals 0. So from here we can see that x is equal to 4 and x equal to minus 2, right? These are the two solutions. But remember, we are told in the beginning that x is greater than 0 only. So we will take this solution, okay, and discard this one. This is not the solution for this one. Okay, so question number 4, easy. Let's move on to question number 5. This is also very interesting and easy question. Okay, we are given the equation of a circle. You can see that this equation, let me write it here. This circle C, it has center at 5 x minus 5 square plus y minus 12 square equal to, this is 10 square, right? So the center is 5 and 12. This is the center and its radius is 10, right? We can draw a rough graph as well, sketch as well, but let's not do this. Okay, find the equation of a tangent to C at the point. Okay, so this point, first of all, I just want to make sure that this point is on the circle, right? Okay, so sorry, x is 11. 11 minus 5 square plus 4 minus 12 square. How much is this, by the way? So 11 minus 5 is 6. 6 square is 36. And this is minus 8 and square is 64. So yes, it is equal to 100. It means this point is on the circle, right? Okay. Now imagine we have point 5, 12, which is the center of the circle. And this is the point uh, 11, 4. Right? So I want to know that what is the slope of line? This is the radius, right? This is the radius of the circle. So I want to know the slope of this one. Okay, so slope of radius. I should not use this term, but let's say, okay. So, okay, so between these 2 points, so y2 minus y1, 4 minus 12 over x2 minus x1. So this is minus 8 over 6. So minus 4 over 3. This is the slope of the radius. So slope of the tangent line. Okay. Slope of tangent line. This is going to be negative reciprocal, so it is going to be 3 by 4 only. Okay. So now I know that the slope is this one and it is passing through this point, 11, 4. Right? So the equation of the tangent line, it is going to be y minus y1 equals m x minus x1. So y minus y1 is 4, m is 3 by 4, and x minus x1 is 11. Okay, so multiply by 4, it is 4y minus 16 equal 3x minus 33. So if I bring on the other side, this is 3x minus 4y equals 33 minus 16. So this is going to be 17. So 3x minus 4y equals 17. This is the equation of the straight line which is tangent to the curve at 4, 11 and 4. Okay, easy. Now the next question is interesting, part B. There is another circle, x square plus y square equal to 4. So this circle has a center at 0, 0, right? X square plus y square, and it has a radius of 2, right? Its center is 0, 0, and its radius is 2. Okay, now you see these two circles. This was C circle, the given circle, and this one. Um, the radius of this one is 10, right? And the radius of this one is 2. So the sum is 12. But what is the distance between the two centers? Okay, one center is 5, 12, and the other center is 0, 0. So distance between these two, it is, you can calculate using this one. Okay, 5 minus 0 square plus 12 minus 0 square. So it is going to be 25 plus 144, and that is going to be 9 and 6 and 1. And remember, 169 square root is going to be 13. Okay, these numbers you should know. I mean, you're not allowed to use calculator here, so you should know that 169's under root is 13. Okay, okay, so very interesting. I have two circles, right? The radius of this one is 10, the radius of this one is 2, but the distance between these two centers, it is 13. So what do you think? They will touch each other or no? They will not yet, right? Uh, so that's how we can prove that that's how we have proved that these two circles do not intersect each other. Okay, interesting. Now let's do this question. Okay, find the x coordinates of the points of intersection in the following curves. Okay, we are given two curves. One is this one and one is this one. Okay, and we need to know where they intersect each other. We need to find the x coordinate of the intersection. Okay, so whenever you have two curves and they intersect each other, so the value of y is same for both of them, right? So in order to find the x coordinate of the point of intersection, we need to equate these two expressions. So 4 log x must be equal to 5 minus 3 over log x square. So x square can be written as 2 log x, right? Okay, so how can I do it? Okay, I I will assume or substitute log x by z, let's say. So it will become 4z equal to 5 minus 3 over 2z. Okay, let's multiply everything by 2z, so it will become 8z square equals 10z minus 3. So this is a quadratic equation, 8z square minus 10z plus 3 equal to 0. So we're going to be 24, and factor of 24 make it 10, so it is 12, 2, no, it is 6 and 4. Okay, and both has to be negative because when we multiply it become positive, and okay, so it is going to be 8z square minus 6z minus 4z plus 3 equal to 0. So if I take 2z common, it's going to be 4z minus 3 and minus 1, so it is 4z minus 3. So I have two factors, 4z minus 3 and 2z minus 1 equal to 0. So you can see that z equal to 3 by 4 or 1 over 2, right? Now, the last part is that, remember, z was equal to log x. Z is equal to log x. So if this is equal to 3 by 4, then you can see, if I convert this log into exponential form, that x has to be equal to e to the power 3 by 4. And similarly, if z, which is equal to log x, is equal to 1 by 2, then x must be equal to e to the power 1 by 2. Okay, so my two solutions are these, x equal to e to the power 3 by 4 or x equal to e to the power 1 by 2. Okay, Again, I would suggest that if in the exam you have extra time, substitute these values in this expression and make sure that they both give you same values of y. Okay, so that's how you can confirm. Okay, so we will do the rest of the problem in the next video. Thank you very much for watching. See you in the next video.